Good morning, everyone. I'm Mohammad Ashfaq Khan, Associate Professor in the Department of Electrical Engineering at the NRI Institute of Information Science and Technology, Bhopal. And today we'll be studying transformer voltage control through this spoken tutorial. In this particular session, we will be covering the introduction and transformer voltage control, voltage variation during tap changing, tap changers and type of tap changers, and details regarding off-load tap changers and on-load tap changers. And to start with, I would like you all to give in a minute to yourself and think about the first question, which is why do we need to control a transformer's output voltage? There has to be a reason why we want to do this operation. And they can be n number of dimensions and number of ways. The only thing that we need to do is to think about it uh, dedicatedly and in an open spectrum. Well, as for a transformer, regulating the voltage is often required in power application or power system, and there are reasons for doing it. And these reasons are: firstly, to supply a desired voltage to the load, to counter voltage drops due to load variations, to counter input voltage changes on load. And apart from these three reasons, a transformer might also be required to control the active and reactive power flows. Though the most important point being controlling the voltage that is being given to the load. For doing this voltage variation, there are two desired operations. One is the voltage increment and the other one is voltage decrement. And both of these are done by using an arrangement which is called the buck boost arrangement. Now this buck boost arrangement feeds in a positive voltage or a negative voltage into the line to increase or to decrease the voltage across the load terminals. Now, with this fundamental, the voltage is varied in a actual power system or a power application. These voltage variations do take place in accordance with certain fundamental. The fundamental that lies here is addition of extra number of turns or removal of number of turns from the circuit. Now this is done by using a device called tap changer, and if at all we assume our tap changer to be connected to the primary side in a step down configuration, that is on the high voltage side of a transformer, then the secondary voltage will be given as Vs1 equal to V1 upon N1 into Ns, and this is shown by the vector OA in the phasor diagram towards the right side. And if at all we want to progress towards a voltage change using tap changer, then uh, there is an intermediate voltage step that comes in between, which is given as Vs2 equal to V1 minus I into XR upon N1 into Ns, and it's shown as a vector OB with a blue vector here as Vs2. Now this XR is the reactance of a saturable reactor, which is introduced as an unbalanced element during the tap changing operation, and this serves a lot of benefits, with the first one being it helps in avoiding sparking at the tap changer terminals, and it avoids the short circuiting of the transformer windings during this process. Now, if we want to further change the voltage, then the tap positions are changed, and the voltage that is obtained is given by Vs3 equal to 2V1 upon N1 plus N2 into Ns, where N2 is the number of turns added in the circuit. to increase the voltage. Now these number of turns would increase the voltage, and that is what we have signified with 2V1 in this particular relation. So when it comes to tap changes, these are required to provide voltage control by changing the turn ratios of the winding. Now these tap changes are placed on the high voltage side, as I've said before, and the reasons for doing this are the voltage per turn in the transformer is quite high, and hence a change of even one turn on the LV side represents a large percentage change in voltage. And apart from this, the LV currents are very high, comparatively very high, and it's difficult to make and break connection without producing any arcing or spark at the terminals. And finally, the LV windings are, for most of the applications, most of the purposes, placed adjacent to the core inside an HV winding. So it it presents an additional difficulty in drawing the taps or connections out of the winding due to space limitations. So under the highlights of these reasons, the transformer taps are placed on the high voltage side. But when it comes to the operation of these tap changers, they can be classified into two type of tap changers. Number one is the off-load tap changer, which is operated when the load is disconnected and the transformer decommissioned before operating taps. And the second one is the on-load tap changer, which remains in service supplying nominal load even when the taps are changing. To get into details of how an offload tap changer works, we must first understand that the offload tap changer is operated when the transformer is taken out of the active circuit. That is, it is switched off. And this is done to avoid the sparking and arcing at the contacts. Even when the supply is interrupted, it is still in use because these tap changes are cheaper and costless. But with the use of these tap changers, the service can be restored only after the tap changing operation is complete. So if we take for example an offload tap changer connected to high voltage winding side with say 6 taps drawn out of the winding, then as I've shown it here, that the high voltage winding is comprised of two sets of equal number of windings, and the terminal 1 and 2 are in the circuit. And for this connection to be established, the tap changer contactors are at position 1 and 2 in the rotary switch. If I try to change the tap positions without disconnecting the transformer, then there will be severe sparking at the tap changer contacts. And for this reason, I disconnect or isolate the transformer from supply, and then I change the tap position from, say, the previous case 1 and 2 to now a new tap 2 and 3. Now with this 2 and 3 tap connection, what happens is the contact that was present at tap 1 is removed and is made at tap number 3. This isolates a section of the winding from the circuit, and therefore the output voltage is reduced. If we need to reduce the voltage further, then the tap positions have to be changed from position 2 and 3, and new new connection has to be formed at contact 3 and 4, as is visible in this particular visual. Now the offload tap changers, they are a linear assembly. That is, the winding contactors or winding contacts are drawn to the contactors, where this linear displaceable contact makes or breaks a connection. This is done by using a movable contact which might be made of carbon brushes or may be made of metal graphites or maybe solid metal contacts. Now these contacts are moved or made or break by using rotary switches which may or may not be gear wheel based, where rotating these rotary switch would change the position of the displacement bar, and hence the taps are changed. Now, the offload tap changes suffer from a very major drawback that the transformer has to be switched off from the service, and this leads to interruption of supply. This interruption is highly undesirable as it would lead to a huge loss of production for an industrial or commercial sector, and can lead to huge economic losses to the service industry as well. And for this reason, we desire to change the taps with the load connected to the circuits. And to perform this job, we use the on-load tap changers, which are also called online tap changers. Now, these tap changes are complicated arrangements, and hence they cost more as compared to the offload tap changers. But while changing the taps, following say the 2 points must be kept in mind. Number one, the main circuit of the tap changer must never be open, otherwise sparking may occur at the contacts. And number two, no part of the tap winding must be short circuited. Though these two considerations are well given care of by the manufacturers, and the operator doesn't really need to give any concern to this, as they are already incorporated in the design of a tap changer. If an on-load tap changer arrangement as shown in the figure is used, with a high voltage winding has taps drawn out of it, then two contactors are generally used to make or break a contact along with two switches and a saturable reactor. Now this switch and saturable reactor assembly is an essential part of this tap changer, because it's just because of this saturable reactor that the obvious drawbacks of tap changing are well taken care of. Now the function of the saturable reactor is to prevent short circuiting of the tap winding. And apart from this, if one of the switch is open, then the saturable reactor carries an imbalanced current in one half of its winding and introduces an additional voltage drop. Say if I open the switch S1, then the current in top half of the winding is reduced to zero, while the lower half carries the load current. In this case, the transformer, say the saturable reactor, presents an additional voltage drop, which takes care of the winding short circuiting and negotiating with the sparking that can be produced. In view of this, the online tap changer is operated in a definite pattern. That is, the two switches are operated along with the contactors to obtain a safe and sparking free operation of tap changing. Now to start up this operation of the online tap changer, the switch S1 and S2, which were initially closed, and the contactors uh, making the contactors in line with the tap 1, then the tap changing operation is initiated by opening the switch S1. Now opening the switch S1 is followed by moving one of the contacts to the tap 2, and once this contact touches the tap 2, the switch S1 is closed again. Now, before closing the switch S1, there is an intermediate voltage step that comes in owing to the imbalance in the saturable reactor. Now, with this, the voltage that is obtained at the load terminals is the resultant of the winding connections 1 and 2. To complete this operation, the switch S2 is now again operated so that the first contact can be moved to the tap contact 2 without producing any sparking. And once this tap position reaches to the tap 2, the switch S1 and S2 are closed again to balance the reactor and hence to cancel out the resultant voltage that can come into picture due to the saturable reactor. The online tap changer offers a number of advantages. Number one, and the most important one, is the load need not be switched off during tap changing operation. And the second one is more number of steps can be obtained when this tap changer is used. This is in accordance with what we have seen before, that if four taps are present in a tap changer, then we can obtain 7 voltage levels by using the same tap changer. And the switches that we are using, they need not interrupt load current, as an alternate current path is always provided, and so there is no sparking or minimal sparking present at the contactors. The online tap changer, as you can see it here, is a very compact assembly with three-phase winding taps present in this arrangement, and the contactors can be moved to make or break a connection, and this would be revealed in a much better way with the visual to follow. So if we consider an area where one of the generating stations supply the grid station, and the grid station is supplying two different loads. One is the domestic load, which is a dominant lighting load, and the second one supplies an industrial load, which can be any inductive load, a large inductive load. Now these two load variations presents now these two load variations presents low varying load pattern on the generating station with during the daytime and nighttime differently, and so the transformer voltage is more likely to vary at different instants. Say if a voltage variation appears across the tap changer, then a controller senses this variation over a certain duration of time. And if at all this variation is not cleared, then the tap positions are now changed to negotiate for the change in voltage. Now, the two contactors that we are talking about are clearly visible here, along with certain vacuum-based contactors, which is chosen to further decrease the sparking that can happen in the operation of an online tap. Now, the tap change connects a great larger part of the winding to the circuit, and hence the voltage dip is compensated by by the system. I've taken in the following major references, uh, and there are contents which are taken from uh, a textbook Nagaratan Kothari for electrical machines by Tata McGraw-Hill. And for any further queries, you can contact me, Muhammad Ashfaq Khan, Associate Professor in the Department of Electrical Engineering, NRI Institute of Information Science and Technology, Bhopal. And my email ID is techno.ashfaq@gmail.com, or you can visit nrigroupindia.com.